So the next speaker is me. As you can see, I am a softly spoken Englishman who knows things about the kernel. In this talk, I will, hang on, no, wrong script. As you can see, the next speaker is not physically present. We're going to try and do this remotely. He's back in Manchester. So, video team is very pleased to try to present your casual acquaintance and mine, Ben Hutchings, doing the kernel talk. I hope he's here. One of these days. There he is. Hi.
Good morning, Curitiba. Okay, I'll briefly introduce myself. AV team, I'm hearing myself echoing over Jitsi, so could you turn that down, please? So, I've been working on the Linux kernel and various related packages for Debian and in my paid jobs for over 10 years now. I'm a member of the Debian Linux kernel team and the LTS team. I'm doing about half of the kernel packaging work and all of the Linux maintenance work for LTS. I also maintain the Linux 3.16 stable update series on kernel.org because that's used in Debian 8 Jersey. As you may well know, Linux releases pretty often. It's about 5 times a year, plus some stable updates every week or so to fix bugs. Some of these features aren't ready to use when they first appear in release because they require integration into distributions either with extra user space packages or some kind of configuration which might be done through systemd or another existing package. I'm going to talk about the new features in Linux 4.19 up to 5.2, the current stable release. So we have lots of new kernel features, some of which made it into Buster. It says here they're in testing unstable. We're actually lagging a bit behind, but hopefully 5.2 will be in unstable in the next few weeks. So a recap of some features that I talked about in previous years. The schedutil CPU frequency governor is supposed to make better decisions about CPU frequency on some hardware. We possibly ought to make that the default. We can't do that on Intel x86 processors, I think, because they use they don't support arbitrary CPU frequency governance. That's actually done by a management processor. But for other hardware, maybe that is a good choice. Zone recording is the new technique used on very high capacity hard drives that does not allow for random writes. You need the DM zones driver for that, which has been around for a while, but you also need the DM zones tools user space package. There is a package for that now, but that's been done by someone who is not a DD and needs a sponsor. If you're interested in that, bug number is 882640. The block layer that's responsible for all disk I/O and disk-like devices was given a major overhaul which required updating all the block drivers, so that was quite a long process, and both the old and new block layers were in place for a while, but that is now completed with Linux 5.0. One of the benefits of that is that you can use some new and more sophisticated I/O schedulers for all block devices, including BFQ, which is said to be quite good for low performance flash drives like you find on single board computers. The RISC-V architecture now has enough hardware support upstream that we were able to start building a kernel image for that with 4.19. And the situation with GPUs on ARM-based SoCs has improved again because there are free drivers for the ARM's Mali GPUs, starting with Linux 5.2. There's 2 different drivers for different generations of the GPU. So, new features. Security hardening is an ongoing process that's both hardening the kernel against security exploits from user space and also providing features so that user space processors can be better protected from exploits. One of these that we enabled a few years back was protecting symlinks and hard links created in sticky directories like /temp. What that means is they're writable by everyone, but users aren't allowed to delete and overwrite each other's files. But it is possible to put traps in these directories with hard links and symlinks that can be used to attack server programs that don't open files in a secure way. So there are new optional protections for FIFOs, also known as named pipes, and for regular files. Those might introduce some compatibility problems, but I think we should consider enabling those by default. Maybe do that as an experiment and see what breaks. Variable length arrays are a C language feature that enables you to use quite a lot of stack space, potentially more than exists in the kernel. Most uses of variable length arrays in the kernel are or were bounded so that it wouldn't result in a stack overflow, but there was always the risk that someone would leave out the necessary check. So those have been completely removed from the kernel, either converted into fixed length arrays or heap allocations instead. The kernel also has enables GCC stack protector, which protects against overflowing individual stack buffers. In order for that to be really effective, you want to have a secret value called a stack canary, which ought to be different per task, because if it's the same for all tasks, then if an attacker can manage to read it from one task, they can attack the kernel again on any task. So x86 already had per task canaries. We now have that on PowerPC and potentially on 32-bit and 64-bit ARM as well, although we'll need some compiler updates. And then reference counts. Bugs in reference counting can lead to freeing objects that while they're still in use, which is very bad. That can be used eventually to achieve code execution in the kernel. The ref count T type is a checked reference count type, and various reference counts in the kernel have been converted over to using that. There were some bugs in the kernel where pages allocated on the kernel heap were then memory mapped into user space. This would result in very bad things, partly because memory mappings and heap pages, heap management use have different uses for the same field in the page metadata, so those would conflict. But even worse, depending on which heap manager was used in the kernel, this could be used to corrupt free lists and achieve code execution in the kernel. So that is explicitly blocked in the kernel now. There's some support on 64-bit ARM for user space to use pointer authentication codes and the memory tagging extension. These are ways to prevent type confusion in user space, which can be used for return-oriented programming and exploiting use after free bugs. Obviously, to take advantage of those, we'll need changes to compiler flags, and those are only available on the very latest version of ARM v8 architecture. ARM and x86 already had provision for preventing the kernel from accidentally accessing user space memory, and that's now available on PowerPC, starting with the Power 9. Sorry, shall I turn down the microphone level? Is that better for you? So that's available on PowerPC, starting with the Power 9 processors. The userfaultfd function can be used for to support live migration of processors between different systems. So that's kind of useful for moving containers around. Even if you need to reboot the host, you can keep the container running. But it's a very powerful facility which can be abused and makes some security issues easier to exploit. So it's now possible to restrict that to privileged users, essentially only to root, and that might be something we should do by default. Kernel address space layout randomization is another thing that makes it harder to exploit return-oriented programming and other things against the kernel. That's been available on several architectures for a while now, and finally was implemented for System Z, which in Debian we call S390X. So I talked last year about the speculation leaks, including Meltdown and Spectre. In the past year, there are even more of these vulnerabilities have been announced. The mitigations for Spectre have also been extended. Spectre variant 1 is about bypassing bounds checks, and unfortunately there isn't a single simple mitigation for that. It requires protecting all of the bounds checks that take untrusted user input. So more and more of those are being protected in the kernel. Spectre variant 2, which is about mispredicted indirect branches, already had a general mitigation in the kernel called ret booleans, but system firmware also needs to be protected against this, and generally isn't being updated. By system firmware I mean the BIOS or EFI firmware. So that's being protected on x86, and user space can also be protected using various new microcoded features. That's opt-in and is enabled for either it's enabled automatically for user space that is sandboxed using seccomp, and it can also be explicitly enabled using a PRCTL system call. So there are two major new issues. There's L1TF, also known as foreshadow, Intel x86 CPUs would speculatively load data from the first level cache using address bits in a page table entry, which would normally provide the physical address, but it would do this in even in a entry that was marked not present, which would be used for a page that had been swapped out and for a few other reasons. This has been mitigated for regular processes by inverting all those physical address bits in all page table entries that are marked not present. But that puts a limit on the maximum amount of RAM and the maximum swap file size you can use, because the physical address bits would be used for a swap file offset in a non-present entry. For virtual machines, the problem is worse. On modern Intel CPUs, hardware virtualization uses two levels of page table. There's the page table installed by the guest VM, which translates from virtual addresses to an intermediate physical address. And then there's the extended page table, which is provided by the hypervisor, in this case KVM, which translates that into a real host physical address. Now, because if the guest VM creates non-present page table entries, those will go through the first level of address translation, and then the EPT won't be used. So it's then able to speculatively access any physical address that the host used and put into the L1 cache. So that's mitigated by L1 flushes on, I think it's actually VM entry, not VM exit. Full mitigation of this will require that you never run a virtual machine on the same core as another process using hyperthreads, unless of course you trust that virtual machine's kernel. If you do, then there's not a real problem here. This did not get fixed in Linux 3.16 or 4.4, so you should not be using those to run untrusted guests. And more recently, the microarchitectural data sampling, or MDS issue, which has a large number of other brand names. But it's a collection of 4 different issues here, but they're all quite similar. Again, Intel x86 CPUs only. They will speculatively load stale data from various internal buffers, and that's quite hard to exploit because an attacker can't easily control or predict what's in those buffers. The mitigation for this has been to flush those buffers whenever the kernel exits a user space. That required new microcode to add the buffer flushing functionality. Older CPUs did not get microcode updates and they remain vulnerable. A full mitigation again would require that you never put 2 processes on the same core unless they should trust each other. So running trusted code on Intel CPUs with hyperthreading enabled is kind of risky now, but it is still enabled by the default because no one wanted to take that performance hit, or to make everyone pay that performance hit. There's now an architecture-independent kernel parameter that controls mitigations for MDS and all the other speculation leak issues. You can specify mitigations equals auto, although that's the default. You can use auto, no SMT, which means hyperthreading or other system multithreading will also be disabled if necessary for full mitigation. And if you trust all the code you're running and you don't need those mitigations, then you can use mitigations equals off. So year 2038 is getting ever closer, and that means that anywhere that the 32-bit time value is used, that's going to wrap around. So we need to switch away from using 32-bit counts of seconds before that time. So the kernel is now internally using 64-bit counts of seconds or 64-bit counts of nanoseconds in k time t. almost everywhere, which avoids this overflow. Most file systems are still storing 32-bit counts on disk. Only Btrfs and X3 and X4 have been updated so far. Hopefully XFS and other file systems which need to be supported in future will get updated. New system calls that use a 64-bit time value are enabled on all 32-bit architectures. However, the other big part of supporting 64-bit time is glibc. That is able to provide both 32-bit and 64-bit time ABIs. However, it can only expose one of these through its headers. It was originally expected that you would be able to define a preprocessor macro time bits similarly as for the 64-bit file sizes on 32-bit systems. However, that choice is actually made at glibc build time, which means that if you want to support 64-bit time on RHF or i386 or any other 32-bit architecture which might last until 2038 or close to 2038, that's going to require SO version bumps in every library that exposes time2. Thankfully, there's a discussion about this that was recently started on Debian Devel, and if you're interested in this issue, I encourage you to participate in that. Cake is not just a nice thing to eat, but also a new network scheduler. Network schedulers are responsible for prioritizing and managing the software queues of outgoing network packets, and in some cases incoming packets. You can select the network scheduler for any network device using the TC command. Cake is based on the existing FQ kernel, which was designed to avoid buffer bloat. In other words, it tries to keep software queues quite small and thus reduce network latency. The FQ part of that stands for fair queuing, which means that it tries to provide fair shares of bandwidth between different concurrent flows. Cake also adds fairness between hosts. So, for example, if you have so if Cake is used in a router and one computer behind that router is making one download and another computer is making 4 downloads, then the first computer gets about half the bandwidth for its one download, and the second computer gets about 1/8 of the bandwidth for each of those 4 downloads. Cake also adds some traffic shaping, which is useful for limiting buffer bloat, and it has some priority support. And finally, it adds coalescing of TCP ACK packets, which is really important for connections that have a slow uplink compared to the downlink. In some cases, the need to transmit lots of ACK packets can limit the download speed, and most home broadband connections have this asymmetry. So all in all, Cake should be quite a good choice for home routers. So system administrators are generally familiar with the concept of system load, which is exposed through /proc/load-avg and through the uptime commands, and usually gathered by your system monitoring software. That is a weighted average number of tasks running or ready to run or waiting for block I/O. When that's greater than the number of CPUs in the system, it might indicate CPU contention. But because it also includes tasks that are waiting for block I/O, it might also indicate that you have I/O contention. So this single number is not that helpful. So pressure stall information was as in Linux 420, and that shows the average time that tasks have been spending waiting, divided into 3 categories. You have CPU contended tasks ready to run but waiting to be scheduled on the CPU. Memory contended tasks are those that are swapping in refaulting a memory mapped file or reclaiming memory, and IO-contended tasks waiting for block IO to complete. This information will be exposed under /proc/pressure and also for each C group through cgroupfs. User space can also monitor for specific levels of contention by opening the file, writing a threshold to it, and then polling. So many ARM-based system-on-chip can have a mixture of fast cores that are not particularly power efficient and slower cores that are more power efficient. ARM has branded this big little. These SoCs have been around for a while, but until recently the Linux task scheduler didn't do a great job of scheduling on these. The default task scheduler, called CFS for Completely Fair Scheduler, was originally designed for systems where all the CPUs running Linux were the same. So they were the same frequency and otherwise had the same capabilities. A while ago it gained support for differing CPU capacities, meaning that they had fewer processing cycles available. But this was only used to improve the accounting of how much CPU time was used. So instead of just counting how long a task had been running on any CPU, it would also take into account how fast that CPU runs in order to know how many cycles the task used. Energy-aware scheduling, which was added in Linux 5.0, attempts to schedule tasks in a way that's actually energy efficient. It uses that record of the task's CPU load to predict which CPUs will have enough spare cycles, and then it also uses an energy model, which is based on data in the device tree, to predict the energy cost of running on each of the suitable CPUs. And then it picks the one that's most energy efficient. But on symmetric systems, or when all of the CPUs are mostly busy, it gets out of the way and the standard scheduler behavior is used. And finally, the packaging changes. There have been lots of little changes since last year. Code signing, which was implemented to support secure boot, has been completed and is in production, not just in Unstable, but also in Buster. Our build logs are verbose by default, as now required by policy, but we do support the build option to make them terse, which is the upstream default. We finally got rid of our private patch system. That was mostly removed in around Linux 3.1 in favour of using Quilt and a version 3.0 Quilt source package. We still used the private patch system to remove non-free files that shouldn't be included in the original tarball. We've now switched over to using the files excluded field in Debian/copyright, which usescan understands. And we also use that field when generating tuples from Git. I went through and fixed almost all of the warnings and errors from GCC, from dpackage, Lintian, and Pycode style and Pyflex. We have a bunch of Python scripts in the source package. There's a libbpf used for dealing with the increasingly poorly named Berkeley packet filter that's used for all kinds of purposes in the kernel now. That's available on most Debian architectures. The changelog has been split, so older entries that predate the last stable release will only be in the source package. This is important because some of our binary packages are actually quite small, and the changelog was taking up most of the disk space that package occupied. We have even more build profiles now that can be used to skip building some packages. So package.linux.no kernel builds only the user space packages, and package.linux.no source skips building the linux-source package, which is used for building custom kernel packages. The UDEBs used in the installer have been reorganized and more consistent across architectures. For example, Wi-Fi drivers were not being shipped on PowerPC, or most of them were not. That's now consistent. And we also include hardware random number generator drivers to solve the lack of entry problem in the installer, and we're including more graphics drivers so that the installer will work in some virtual machines on ARM. So that's it for all the changes that I thought were interesting enough to talk about. I'm going to switch over to a different program now to do the questions and answers.
Okay, there's about 15 minutes for the questions. Got the first one here. Please wait. So, meanwhile, anyone know any good jokes? So, just going to keep babbling to avoid dead air. Does anybody know any good questions? For those of you who don't know, this is the first time we're doing a remote talk at DebConf. Oh, there he is. Here's your question.
Hi, this is Rafael from Canonical. I have a question related to 32-bit kernel, and as far as I know, it's not mitigations for Spectre and Meltdown, including MDS, are not enabled by default if you're not enabling more than 4 gigs of RAM, so using physical address extension. So my question is related to this. Is there any plans regarding, enabling those mitigations for 32-bit if they are needed? And also, what about 32-bit support? What's your view on that? Because some of the distributions are thinking on dropping the support and all. So
I'm sorry, but I'm not hearing that question clearly.
Could you repeat that?
Can you hear me now? Is there anybody in there?
Blink once for no, twice for yes. Can you hear us? Nope. Please hold. You are number 17 in the queue. I think maybe we should switch to relaying through ILC.
I can take questions from ILC if that's better.
Oh, can you hear us? No, still can't hear us.
Let's first start with the question from Wouter, I guess. He
Okay, I can hear more clearly now.
Okay. Yes, ask questions of ILC. I'd say go with, let's go with that one. Okay, good. Don't make me do any work, it's no good.
Okay, Wouter asked, is the checked ref count thing a feature of GCC, or is it something that is implemented in the kernel? It's entirely implemented in the kernel. It's not the reference. The checks on the reference count are in some cases done using inline assembly, but generally it's mostly C code and not a compiler extension. Okay, so Raphael asked about i686 support. We don't have mitigations for Spectre and Meltdown by default without PAE enables. Right, we don't have a mitigation for Meltdown on there, but we do for Spectre. Do we see i686 support continuing? Well, I think that's the support for i386, which really means i686 now, is I think a decision for the distribution as a whole, for the project as a whole to make, or possibly for the release team to decide whether we release that anymore. I think we might want to think about dropping support for the kernel 686 flavor and requiring PAE because Meltdown and some other mitigations depend on that. Lucas asked about the pressure stall information. Any chance getting it backported to 4.19? I don't see that happening. I don't think it's a useful feature, but that doesn't meet the requirements for a stable update. Apollon asked, would you consider allowing unprivileged user namespace clone by default? I think we would have to review recent security issues and see whether whether or not there have been recent security issues that's still mitigating. If the issues that is mitigating have stopped occurring, then perhaps we could enable it by default. Gusev, I don't know if I'm pronouncing that right, asks, how soon is kernel 5.2 planned to make its way into Debian? I would hope within the next week or two. There is a merge request on Salsa, which I need to review, which would update us to 5.2. Medical Way asks, when will Debian 10 have a backported kernel? I would say probably a week or two after we have that in unstable. It's got to make its way into testing before it's uploaded to Buster backports. Indigo Blue asks, is EAS a good feature for energy-aware scheduling on a hypervisor? I would suspect not, because the hypervisor can move virtual CPUs around between physical CPUs. If the virtual machine is pinned to specific processors and the hypervisor provides information about those through device tree or some other mechanism, then it might be possible, but I don't think that's something that's being done yet.
more questions?
No. 3 minutes left. 3, 2.5 actually.
Okay, I guess then all questions asked, I guess. Last chance.
I guess that's everything. Thank you all very much for coming along on this sort of experimental maiden voyage. Thank you for letting us try this. Huge hand to the video team, please, for having worked their asses off to get this working. And see you next time.
Yes, thanks very much to the AV team.